Good morning, students. So I hope all of you understood up to question number 12, isn't it? So today we start from question number 13. So today here we have to do question number 13 and question number 14. Is it clear? So if you see the question number 13 here, the question is given in this way. In the given figure, a square OABC is inscribed in a quadrant OPBQ. If OA equal to 20 centimeter, find the area of the shaded region. So that means here we have to find out the shaded region. As you see here, the figure is given, isn't it? Okay, now let's start here. Let's see how can we do this one. So as you see here, the figure is given, this one. In this case, the quadrant as mentioned here, OPBQ, isn't it? And in this diagram, here is square given OABC. So now in this case, the length of OA is given. So that means this OA length is given here, isn't it? And what we have to find out? We have to find out the shaded region here. So here to find out the shaded region, if we find out the area of this quadrant and then this OABC is already mentioned here is a square, and if we subtract from this quadrant this area of this square OABC, then which portion remain here? So obviously remain here the shaded portion, isn't it? And this shaded portion we have to find out. Is it clear? So that's why here what you have to do, first of all, here we have to find out the area of the quadrant as well as we have to find out the area of the square. For quadrant, so obviously this one is a sector. So there is a formula of sector, and which one is theta by 360 into pi r square. Theta is the angle here, r is the radius. So in this quadrant, the radius not mentioned directly. So that's why what you have to do, we have to find out the radius. Only for that reason here, what you have to do, we join this OB. If we join this OB, and now here already we know OA. Since it is a square, so that means the AB length are also same, isn't it? So here OA equal to 20 centimeter. That means here AB is also 20 centimeter. If OA and AB we know, so easily we can find out the length OB we can find out here, isn't it? So that's why first of all, as you see here written, this one, in triangle OAB, which one? OAB, this one is a triangle. And in this triangle, if we apply the Pythagoras theorem here, so OB square equal to what we write? OA square plus AB square. And OA and AB we know 20, 20. So that's why here we write 20 square plus 20 square. And how can we find out the square root here? 20 square in plus 20 square. That means 2 times of 20 square. So if we take the square root, OB equal to root over 20 square. Root over 20 square means simply 20. Ultimately here OB equal to how much we get here? 20 root 2. Is it clear? Centimeter. So this one is first of all we get. So OB. Now this OB we consider as a radius also because it is a quadrant, isn't it? So that's why this OB we consider as a radius. So radius equal to ultimately here we get 20 root 2 centimeter. And now easily we can find out the area of the quadrant here, isn't it? The area of the quadrant OPBQ. So this area we get theta by 360. That means here, as you see here written, theta by 360. That means 90 by 360 into pi means 3.14 into radius means 20 root 2 whole square. And if we calculate this one, 90 by 360 means we get 1 by 4 into 3.14, and 20 root 2 whole square means ultimately we get 800. And if we calculate this result, So finally we get here 628 centimeter square. Is it clear? After finding the quadrant, now here we have to find out the area of the square here. So area of the square means OABC. This one is the square, and we know the area of square formula is what? Side into side, side square. So that's why as you see here written 20 square means ultimately 400 centimeter square. So here finally we have to find out the shaded region. That means these two portions we have to find out. And how can we find out these two? The area of the quadrant minus area of the square. So as you see here, area of the quadrant minus area of square. So that means 628 minus 400. Ultimately here we get 228 centimeter square. Which one is our required answer? So that means the area of the shaded portion is how much? 228 centimeter square. Understood? Okay. Now after 13, if you see the next question, question number 14, and the question is given here in this way: AB and CD are respectively arcs of two concentric circles of radii 21 centimeter and 7 centimeter and center O. If angle AOB equal to 30 degree, find the area of the shaded region. So as you see here, the question is given here, this one, and now here we have to find out the solution here. Let's see how can we do this one. So if you see the diagram here, diagram is here mentioned AOB, the bigger one, isn't it? So which one also we can write OAEB. So this one is the area, as well as the smaller part. If we consider, the smaller part is here OCFD, isn't it? So now we have to find out the area of this shaded portion. So here we have to find out the area of this shaded portion. So how can we find out? Very simple, this one. So the bigger part is this one. From this bigger part, if we subtract the smaller part, then which portion remains? So obviously this shaded portion remains, and this shaded portion we have to find out. So no doubt this one is a sector here, because if we see the bigger one, OAEB, if we take the bigger one, so here the radius is given how much? 21 centimeter. If you take the smaller one, then here the radius is mentioned here how much? 7 centimeter. So no doubt here we have to apply the sector formula, and from the bigger part, if you subtract the smaller part, then here this shaded portion remains. So that's why as you see here the written area of the shaded region, area of sector OAEB minus area of sector OCFD, as you see here written, isn't it? So now here if we apply the sector formula in both cases, so no doubt here the angle is how much? 30 degree, and for the bigger one the radius is 21 centimeter. So that's why here we have to write theta by 360 into pi into radius is how much? 21 centimeter square, minus the smaller part, theta by 360 into pi into the radius is how much? 7. So that's a 7 square. And now from here theta by 360, if we cancel this one, then here remain 1 by 12 into, we keep pi same, and then we take right here 21 square minus 7 square. So here it is of the form a square plus a square minus b square formula. So that's why here we have to apply a plus b into a minus b. Is it clear? So that's why here we write after that 1 by 12, pi means we can write 22 by 7, and then we write 21 minus 7 into 21 plus 7, a plus b into a minus b. And if we calculate this one, we get here 22 into 14 into 28 divided by 12 into 7. And after that, if we calculate this result, and finally we get here 308 by 3 centimeters square. Is it clear? I hope all of you understood this question number 13 and question number 14. So if you understood these two questions, then you have to copy these two. And in our next class, we continue this exercise and we start from question number 15. Is it clear? Okay. Thank you.